Hello everyone. In this project, we are building a smart door lock system using the STM32 Nucleo F446RE with RFID authentication. The idea is simple. When an authorized RFID card is scanned, the door unlocks, and if the card is not registered, access is denied. This gives a secure and contactless entry method commonly used in hotels, labs, and offices. We are using the MFRC522 RFID module which communicates with the STM32 through SPI protocol. The MFRC522 supports an operating frequency up to 10 MHz, so we choose a suitable SPI baud rate prescaler to make sure the clock from the STM32 stays below the limit for reliable communication. In the wiring, the SCK line provides the clock. MOSI sends data from STM32 to RFID. MISO sends data back from RFID to STM32. The SG or chip select pin is connected to GPIO pin to enable module during communication, and the reset pin is used to reset and initialize it. The module is powered with 3.3 volts and a common ground is shared between the STM32. With this setup, the microcontroller can read each card's unique ID and decide whether to grant or deny access.
Okay, so I'm Sai Nidhi and my contribution towards the project was to interface an LCD display and servo motor. So after interfacing the RFID reader, we started to work with the LCD display. So we used a 16 cross 2 LCD display here. So by default, the LCD will show us door lock, and whenever a valid RFID card or tag is brought near the reader, it will show us access granted or access denied. So this will show for 3 seconds, and then after 3 seconds, it will again show us door lock by default. So after interfacing the LCD, we moved to interface the servo motor. So for servo, we chose an SG90 servo. So this one comes with 3 pins. So one is the PWM pin, which is used to set the servo speed or change the direction or set the angle. So this pin is connected to the unlock pin, that is A0 pin of our Nucleo board, and then the other 2 pins are ground and VCC. So this servo operates at 50 Hz frequency, while our STM clock is set at 180 MHz. So we had to use we had to set the prescaler and counting frequency appropriately so that our servo would work as intended. And the primary bottleneck here was choosing the power supply, as I don't want to use the 5 volt power supply for servo, that is the 5 volt power supply from STM, as the servo might draw excessive current which might as well damage the board. So I decided to use 1.5 volt AAA batteries. So I used 4 of those batteries, and with using these batteries I was able to make the servo work as intended, and then we were able to finish the project successfully.
Create a new project in the STM32 Cube software and select for your required part number of your Nucleo board. Now give a project name for your project and then click next in order to finish. Now this will create a IOC file where click for the clock configuration and set it as 180 MHz. Now in the pinout configuration, select for a system core and RCC. In the RCC, select as crystal ceramic resonator. In the SYS, select serial wire. Now in the connectivity, press SPI 1 and full duplex master as mode and set the prescaler 16. This is in order to match the frequency of RFID. Now in the timer section, plus for timer 2 and select as channel 1 PWM generation and set the prescaler as 200 minus 1 and the counter period as 18,000 minus 1. And now in the pin node configuration, set the selected pins that you wanted for your LCD and also for a reset pin. We can see that we used a header called as liquid crystal IC2 and also an RC522 header which is used for RFID in the main code. Now on the left side you can see the INC folder where we have included our headers. Similarly, we also have the C coding for the LCD file and also the C program for the RFID. And we have included all those files inside our source folder. Now we can come to the main program. The main program we have the function called set servo angle. Now this part of the code converts an angle value into a PWM pulse length which controls the angle is 0, the door stays locked, and when it's 180 degrees, the door unlocked. And also now here we can see the pin specification for the LCD. Now in the while loop is the main logic of the whole program lies. Inside the while loop, the controller repeatedly checks if a card is near the reader using MFRC52 request. If a card is detected, its unique ID is read and stored in SNUM. Then the code compares these ID values with the predefined ones. If they match, it displays access granted on the LCD, and the servo rotates from 0 to 180 degree to unlock the door. After a short delay, the servo moves back, locking the door again. If the ID doesn't match, the LCD shows access denied. When no card is present, the LCD simply displays door locked.